Optimization, let's go. You've been commissioned to design and build a 650 cubic foot square-based open top rectangular steel holding tank for a paper company. What? Often problems like this are accompanied with a picture. This one is not. I'm gonna make my own picture. Let's draw this. It needs to have a square base, but I'm gonna draw it as if it was three-dimensional, so I'm gonna make it look a little rhombusy. There we go. And you don't have to draw this, but it's just gonna help me do what needs to be done with this problem. What I can't see is dotted. Back in elementary school, I was taught how to draw these things. Not that that looks very good, but there it is. And because it has a square base, I know that this dimension and this dimension are the same, and then we're gonna have height. Okay, open top, meaning that it does have a base, does not have a lid. Rectangular steel holding tank for a paper company. The tank is to be made by welding thin stainless steel plates together along their edges. As a production engineer, your job is to find the dimensions of the base and height that will make the tank weigh as little as possible. In other words, minimize the surface area. Okay, two formulas. One thing I know, one thing I don't. Here we go. Find the surface area, confirm you've indeed found the minimum. Indeed I have. What do I know? I know the shape, but what numbers do I know? I know the volume. Similar to the last problem, I'll start with what I know, and what I know is the volume, and the volume of this tank is x times h, and so we have 650 equals x squared times h. Let's solve it for h. Solve it for x if you want to complicate your life. Who wants to complicate their life? Not me. There we go. 650 over x squared. All right, switching colors. It's for fun. What I need to know is the surface area. And that would be, okay, well, there's a square down here. And there's only one square because it is a open top. And again, usually there's a picture, it makes it clear, but this has just open top, so no square up here. Yes, square down here. And then there are 4 of these rectangles all around the sides, and each rectangle is x by h. X wide, h high. Okay, let's keep going. What are we gonna do now? Well, I have 2 variables on this side. I really want 1, so let's take h out and put that in its place. So we're gonna have a equals x squared plus 4x times 650 over x squared. If you're looking ahead, you'll notice that this x cancels with one of those. So we have x squared plus, all right, 650 times 4 is going to give me 2600. 2600, and this x cancels with that one. Technically, it gives me that. I'm skipping a step. All right, I'm ready to take a derivative if you are. You ready? Good. 2x minus 2600, x to the negative 2. We'll set that equal to 0. Let's solve. 2x equals 2600 over x squared. I moved this to the other side and went ahead and moved that x squared down. Cross multiply, 2x cubed equals 2600. X cubed equals 1300, and then I need the cube root of 1300. And in case you needed to know and never knew, it's under the math menu. We did this on the last problem, but math, cube root of 1300. Whoops, let's try that again. 10.914. 10.914, there we go. All right, well, they asked, whoever they is, I don't know, as a production engineer, dimensions. Oh, dimensions of the base and height that will make their tank weigh as little as possible. I need the dimensions of the base and the height, that would be the x and the h, that will make the tank weigh as little as possible. Find the surface area as well. So let's also find the height. So 650 over x squared, this is where I'm looking. We're gonna plug some numbers in, crank out some more answers. So 650 over, before we do that, let's store this as x. You know what, let's not. When you store something as x, you run the risk of the calculator reassigning it very soon. You know, anytime you graph, it uses the variable x. I'm gonna call it b, actually. I probably should have done that to begin with, but I'm gonna store it as b in my calculator, just so I'll know. So 650 divided by b squared, b for base. There we go, 5.457. By the way, that's half of this number, not a coincidence. Just the way it's configured, it does that. This one was the same, that one is half. It's crazy. So 650 divided by b squared. Just making sure I did that right. Okay, yeah, I'm good. 5.457. And let's put units on this. This is feet. This is feet. And we need to find the surface area. So the surface area will be x squared plus 2600 over x. I'm looking at this line when I say that, right there. And when I plug that in. Oh, by the way, you could have gone up to the very top and done it this way as well. Totally fine, same thing. So x squared, which in this case is b squared, plus 2600 over b. And I have a surface area of 357.342 square feet. All right, let's confirm that we have indeed found that. What's the smallest x could be? Well, it can't be 0, but it could be anything above 0. And what's the biggest it could be? Infinite, theoretically. So here we go. We got our number line. We're going to start at 0. We're going to go all the way to infinity. And this, 10.914, is our critical value. And I want to make sure that this truly is a minimum by doing the same thing we just did. So I'm going to go a little faster. Let's plug in the surface area, which is that right there. So y equals, then we're going to type in x squared plus 2600 divided by x, or x to the negative 1, either way. Second and table, and I'm going to plug in a number a little less than 10, or a lot less than 10, and a number greater than 10.914. And so like 100 goes there, and something seems very wrong. Oh, I didn't plug in the derivative. Silly math teacher. Silly, silly math teacher. 2x. I'm sorry, y'all. There we go, that's better. So function is decreasing, area is decreasing, then area is increasing. So this must be the minimum area, and that is our explanation. So a prime is indeed negative, a prime is indeed positive. A prime is negative, a prime is positive. This truly is a minimum, and we're gonna write that down. X equals 10.914 is the base length, white out. That corresponds to a minimum surface area. Why? Because a prime changes what? Changes signs. Changes. Having a hard time writing right now. Changes signs from negative to positive. There. Almost the same wording as the previous problem. But basically the function A, is decreasing then increasing. That must be a minimum. Found it.